Hello, everybody. Today we're talking about the properties of exponents, and we have two learning objectives. First, we have I can simplify expressions using the property of exponents, and then second, I can simplify expressions using zero and negative exponents. Now we're going to focus on the first one immediately, and then we'll get into the zero and negative exponents later, just because they're a little trickier. But when I'm talking about these properties of exponents, we're talking about when we are multiplying with exponents, when we have parentheses with exponents, when we are dividing with exponents, and then actually basically that's about it. Then we have different parentheses rules that we're going to look at. So first off, let's start with how these things relate to each other. Remember, exponents is just a way to write things out when it's repeated multiplication. So if you have repeated multiplication of the same base, you can combine those together by simply adding those exponents together. So in this example, you have a to the m power times a to the nth power, and we can combine those together by saying a to the m plus n power. Now, when it comes to division, it's a little trickier, but it's also related. When we're talking division, if you have the same base, a and a, you can combine those together by subtracting those exponents, m minus n. Now, this is only true as long as a is not 0, because a is on the bottom here. You can't have 0 on the bottom. Most of the time, we don't have to worry about that. One thing I want to pause here for, when we're talking about multiplying and dividing, it goes hand in hand in remembering, because multiplication is similar to addition. Division is similar to subtraction. And that's exactly how their exponents are related to each other. If I'm multiplying powers, I add those exponents. If I'm dividing powers, I subtract those exponents. Now, when we're talking about parentheses, it's actually not too hard to remember as well. When you have parentheses and you have exponents inside and outside, what you do is you multiply those exponents together. And it doesn't matter where or when, as long as you see exponents inside and outside parentheses, you're going to multiply those together. So for this problem, you have a times b on the inside with an exponent m on the outside. What this means is you have a to an invisible first power times b with an invisible first power. So you're going to multiply those ones times the m. Basically, you're distributing here. M times 1, which gets you a to the mth times b to the m power. You see what I mean? Even if I'm multiplying inside parentheses, I'm just multiplying those exponents together. And the same thing if I am dividing. These have invisible 1 exponents. So I have exponents inside and outside the parentheses. To combine them, I just distribute that exponent to everything inside. M times 1, m times 1, m, and I'm simplified. So big three things with these properties. If you're multiplying with the same base, you add together. If you're dividing with the same base, you subtract together. And then if you have parentheses, you multiply those exponents. Let's see a couple examples in the delta math. Now, delta math, you have 10 problems that look similar to this. When you're dealing with these ones, pay attention to what operation is going on. In this problem, we have 3 to the third times 3 to the fourth. Multiplication is going on. So make sure we have the same base, which we do, 3 and 3. Then just add those exponents together. Since it's multiplying, deal with those exponents by adding. 3 plus 4 makes 7. This is what I like about the rule and the property, because if I have 3 to the third, that just means I have 3 threes. If I have 3 to the fourth, I have 4 threes. Combine those all together, which makes 3 to the seventh. And we can follow that shortcut for every single time. Let's see if I can find one for division. Oh, perfect. I didn't have to go very far. Dividing, make sure you have the same base. 3 and 3, okay, we're good. Then you subtract those exponents. So 3 to the fifth divided by 3 to the first, that's 5 minus 1. I want 3 to the fourth. And again, look at it expanded, and you can see where the shortcut comes from. I have 5 3s when I'm talking 3 to the 5th. 3 by itself is just 3 to the 1st, 3 by itself. And since we're dividing, we can divide out, we could cancel out like terms. 3 and 3, they're gone. What's left over? 3 to the 4th, which is the same as subtracting those exponents. Now the last property, oh, perfect. I honestly, I didn't plan that, guys. That was awesome. But dealing with those parentheses, when you have parentheses, you multiply those exponents together. So for this one, I have 6 times 3, which just makes 18. Take a look at this expanded, and you'll see why it is the way it is. 4 to the 6th power means I have 6 4s. But I have 3 of these because it's 3 on the outside of that parentheses. So I have 3 groups of 4 to the 6th power, which means all together I have 18 4s. How did I get the 18? Well, I can expand and count them up, or I could just simply multiply those exponents. So there's properties of exponents. You're talking multiplication, division, and parentheses. When you're dealing with those, add the exponents, subtract the exponents, and then as you can see here, you want to multiply the exponents. Now, the other thing we have to discuss are negative and zero exponents. Negative and zero exponents. Let me start off with a zero exponent because this is one of my favorite things, guys. If I'm talking zero exponent, that's our second learning objective. If I'm talking the zero exponent, anything to the 0 power automatically becomes 1. It could be a to the 0, x to the 0, z to the 0, hot dog to the 0, cat to the 0, whatever it is, raised to the 0 power turns it into 1. Now, negative exponents are a little bit different. When dealing with negative exponents, it does something a little strange. It moves that entire power to the bottom of a fraction. It makes it its reciprocal. The way I like to think of it, guys, negative is a sad exponent. They're not happy with where they are. So those negative, those sad exponents, they move to the other side of our fraction. Here's something to think about. Let's say I had 3 to the negative 2 power. That's not happy with where it is, but it's also, it could be written as 3 over 1 because 3 divided by 1 is just 3, right? So what this means is it changes because it's a negative, it's a sad exponent, it flips sides. Now this 3 squared is happy because he moved sides, and then 1 moves with it. Now 3 squared is 3 times 2, so this just equals 1/9. Negative exponents, they flip sides. Zero exponents turn everything into 1. Okay, so let's see these in action as well. Going back to our delta math, dealing with our delta math problems, we're talking negative and zero exponents, level 1 and level 2. Using the same properties, but now dealing with the exponents, and you have multiple choice. So that helps us a lot, right? Anyways, dealing with our parentheses, we have exponents inside and outside. What do? You multiply those together. So negative 2 times negative 1 becomes positive 2. I want 6 to the positive 2 power. I want this option here. Let's try another one. Let's try one without the parentheses. Ooh, here's 1 to the 0 power. Dealing with parentheses, that just means we have to multiply. Negative 3 times 0 becomes 0. So I have 2 to the 0 power, which means it's 1. See if I can find another one. Do I have some without parentheses? There we go. Here's a multiplying one. When you're multiplying, add those exponents together. 0 plus that invisible 1 means it's 1. 3 to the 1st power is 3. Invisible 1, add them together. 3 to the 1st becomes 3. Let's see if I can find a dividing one here. Multiply, multiply, multiply. Yeah, perfect. Dividing, you subtract those exponents. Same base, 4 and 4. So I subtract those exponents. Negative 8 minus 2 Negative 8 minus 2 makes negative 10. It's negative. It's not happy with where it is. So it moves to the bottom. I want 4 to the 10th power on the bottom. Exponents, you subtract when dividing. Subtract gets you that negative 10. Not happy. It's negative. Moves itself to the bottom. So that's kind of a lot going on in this video, guys. Feel free to email me at any time. Make sure you can figure this stuff out, right? You were multiplying powers. That's when you add the exponents. Dividing powers. That's when you subtract the exponents. Multiplying with parentheses, or I'm sorry, exponents with parentheses, multiply the exponents. And then you saw negative and zero exponents and how they react to the bases as well. See you guys later.